Hi, everybody. Welcome to Lesson 5, which we're going to talk about this number called the correlation coefficient. And believe it or not, this is our last lesson of the course. This is the last video you have to watch of me. Actually, I'm kidding. Next week, you have to watch a video. But this is the last lesson. You're not getting a lesson next week, but this is the last lesson you get from me. So let's dive into it here. So consider the following scatter plots. Sketch a line of best fit for both of these. So remember, when we sketch a line of best fit, we're kind of going to pick a line that goes through the middle. There's some points above and there's some points below, but those look like my lines of best fit there. Again, I just freehanded them. Is there a positive linear relationship for both of them? Yes, they're both positive. They're both increasing, and they're both appear to be pretty linear. There appears to be that kind of straight line shape. Do they have a positive slope or a negative slope? Well, since they had a positive relationship, that means they have a positive slope. Which scatter plot is a stronger linear fit? So which of these lines of best fit would you say is stronger? So I'm going to have you think about that for a second. Which of these lines of best fit here are stronger compared to each other? I'm hoping you said this one here, this one on the left. I'm going to say the one on the left. Why is that a stronger fit compared to that one? Well, the dots are closer to the line. The data is closer to the line, which means our predictions, remember, linear regression, scatter plots are all about making predictions. Our predictions are better. Our predictions are better. Here, my predictions are awful lot more. These points are pretty far from the line, whereas over here, a lot of the points are close to the line. So what we're going to do is we're going to quantify this fit. How good of a fit do I have? We're going to quantify it. That means we're going to give it a number with this thing called the correlation coefficient. And we use the letter R to represent the correlation coefficient. I don't know why we use the letter R. Pearson is the guy who came up with it. So maybe because Pearson has an R in his name, we use R. But we use the letter R for the correlation coefficient. And it's a measure of how strong the fit is, how strong the linear fit is. Is the data close to the line is what this number tells us. And the way that it tells us this is it's trapped between 1 and -1. R has to be between -1 and 1. -1, R equals -1 is a perfect negatively sloped line. All the data is perfectly in a line, and the line of best fit goes through every single point. Why is it negative? Well, because it's decreasing. R equals +1. Well, what do you think that is? That's a perfect positively sloped line. The data perfectly passes through every single dot. So this is ideal. So the line crosses through every point. The line hits everything. The line hits every point. But that's not usually what happens. Usually, we have this kind of strong clustering where the data is pretty close together. It's not perfectly, a line can't go through all the points, but there's this strong fit where the dots are close to it. This would be like R equals 0.9. 0.9 is pretty close to 1, so this is perfect. 0.9 is a good R value. This is a strong R value here. 1 is perfect. We don't get that all the time. But we want like 0.9, 0.95. We want numbers close to 1. What is -0.9? The negative is just telling me the direction. So -0.9 is still just as strong. The negative just means that the line is decreasing. I could have R equals like 0.7. That's like a moderate fit. That means the data is kind of close. It's a little bit spread out, but there's a good fit. It's not perfect. I would say this is a moderate strength here. And again, negative would mean the same thing. It's still moderate. It's just decreasing. And the last thing would be like 0.3, where the data is kind of scattered around. There's not really a lot of a pattern, but I can draw a line through it, but it's not a good fit at all. So if there's data kind of scattered everywhere, this would be like R equals 0.3, where it's weak. We don't want that. That's bad. We want our data to be very strong. And again, the negative number is just as strong. It just tells us the direction. So let's do a couple problems, and then we'll call it a unit, and we'll call it Algebra 1. So the table below shows 6 students' overall averages and their average in math. So this is their overall average, and we want to predict their math average. So write the linear regression equation. I saved time and prepared for this lesson and already have the data typed in here. So here's my scatter plot, and I want to create the regression equation. So how do I do that? Well, I hit y1, squiggle, y equals m x1, x1, nope, come on, Sparky, mx1 plus b. Y equals mx. It'd be nice if I could have an x in there like I asked for. Oh, Desmos, you're killing me right now. Oh my goodness, why can't I do this right? Y squiggle m x1 plus b. There we go. There's my line of best fit passing through this data. So here's my line of best fit here, passing through as many points as we can. So we get the equation. There's my m and there's my b. 0.83 is my m. Y equals m 0.83x plus b is 14 point. Tell me how to round. 100th, 2 places. 14.07. 14.07. So there's my line of best fit. Well, if you look here on Desmos, you get the correlation coefficient. There it is right there. There's your R value. We don't want R squared. So we're saving that for AP Stats if you take that your senior year. We're looking at R right here. R equals 0.9248 to the nearest hundredth, so 2 places. R equals 0.92. Is that a good R value? Yeah, that's a good R value because the data is really close to the line. It's off, but it's not that far off. So there's a strong positive association or correlation because R is close to +1. Remember, 1 and -1 are those magic numbers. The negative is fine. That just means there's a negative association. It's still strong, but there is a strong positive association because I have a good R value for my data. It's just a quick check of, does this line actually make good predictions for me? Let's do another. So the data given in the table below shows some of the results from study comparing the height of a certain breed of dog based upon its mass. So what's the mass of the dog? How tall is the dog? Write the linear regression equation. Luckily, I already have the data typed in. This would be painful for me to type in. So let's hit plus to view it. Ooh, this is a rough scatter plot just by me looking at it. It looks like it's going up, but this guy over here really throws me off. We had a really fat dog that wasn't tall, but this looks rough. So let's see if I do better this time. Let's get the regression equation. How do I do that? Y1 squiggle m x1 y equals, remember you got to use the x1 and y1 squiggle mx1 plus b. Bam. So you can see that line of best fit, these data points are not close to that line of best fit. This line of best fit here is a little bit off, and it's really off because this guy down here really throws us for a loop. He's an outlier, right? He's unlike the other values. So let's write the equation, rounding to the nearest 10. In your problem set, please round to the right numbers, one place. 1.9x plus b, 29.8. 29.8. State the value of the correlation coefficient to the nearest tenth. So what's my R value? My R value is 0.337. So R value is 0.337, nearest tenth though. So one place, do I chop or round up? I chop. R equals 0.3. This is a bad R value, which we expected because look at this scatter plot. The data is not tightly packed to the line like it is here. So this is a bad R value. This tells us there is a weak association. There's a weak positive correlation between what? Mass and height. It's not really a good prediction. We're not going to make good predictions based on this equation here. So that's what R does. It kind of gives us a quick check of, is this a good line that I should be using, or should I not be using that line to model the data? Couple multiple choice questions, and then we're done. Which value of R represents a strong positive linear correlation? So I want strong. That means I want to be close to R equals 1. Remember, 1 is perfect. 1 is perfectly strong. So definitely not 0.1, definitely not 0.34. So do I go with 0.89 or 1.04? Well, remember, R1 is perfect. R cannot be bigger than 1 or negative 1. It's trapped between. R is trapped between negative 1 and 1. You can't be outside there. So that's why I have to throw out 1.04, because that's not a possible value. So 0.89 is pretty close to 1. Which correlation coefficient, which R value, shows the strongest relationship? So that means, again, I want to be close to these extremes here. 0.23 is not strong. 0.6 is not strong. Who's stronger, 0.86 or negative 0.92? Well, who cares that it's negative? This is stronger. The negative just tells us the direction. This has an R value that's basically the same as 0.92. So this is the best R value, which is the strongest because it's closest to R equals negative 1, compared to this being close to R equals 1. And finally, one more. Given the scatter plot below, which R value would most likely represent the correlation coefficient? So if I draw my line of best fit here, that's a pretty good line. That's a good line. So I'm going to get rid of 0.28. It appears to be a positive correlation, so I'm going to get rid of the negative number. And it's not perfect. R equals 1 is perfect. This is not perfect, so I'm going to go with 0.88 because it's a pretty good fit of the data. So hopefully you feel comfortable using Desmos. The R value is already there. It's just something new that we're going to talk about. Hopefully you remember, you want to be close to 1. 0.92 is good, whereas this one here, this had an R value of 0.33. That's no good. That's not a good R value. The data is really scattered, and the line is not a good fit. So that's our last algebra lesson. You have a problem set to do where you're going to have to use Desmos to do some linear regression work, and then you're done with Algebra 1 mathematics. Next week, you will have a survey and a video to watch for me, but it's going to be me saying how much I miss you guys, and I'll leave all the other emotions for next week. Next week will be our soft, warm, and fuzzy week where I tell you how much I'm going to miss you guys, even though it's been a while since I've seen you. But get your problem set done and keep up the good work. Finish strong, guys. Finish strong.